Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12th. We are doing chapter number 5 of class 12, that is nothing but continuity and differentiability, as you can see in the title also. And we have started solving questions of exercise 5.1. In this list of question we have completed till question number 25. Now in this video we're gonna do question number 26, 27, 28, 29 of this exercise. Let's move forward in this video. So, okay, let's read the question first. Okay, so find the values of k so that the function f is continuous at the indicated points in the exercise 26 to 29. Okay, so from 26, question 26 to 29, what we have to do, as you can see, we have to find the condition on k such that the function will become continuous on an indicated point. Okay, so let's begin with question number 26. As you can see, we have defined a function f of x as it is defined for x not equals to pi by 2, it is defined as k cos x divided by pi minus 2x. And for x equals to pi by 2, it is defined as 3. So what we have the indicated point over here, our indicated point is x equals to pi by 2. So we have to find the condition k. First of all, understand what your question is demanding. Okay, I will write it here. The question is demanding that we have to find k such that the function is continuous at x equals to pi by 2. That means find k such that, if I give you more information, for such that you have a proper symbol in mathematics, that is like reverse e, that is like this. Okay, such that f is continuous at x equals to pi by 2. Okay, now let's do this. Okay, we know that it's very easy question for you now, guys. Now that how to check the continuity. For to check the continuity, what do you have to do? First of all, check whether the function is defined at that point. As you can see, the function is defined at x equals to pi by 2. The value is 3. Now we have to check the function value is same as the limit value. So for that, first of all, we have to find the limit of the function. Okay, so what we want, that means our function value f of pi by 2 is defined as 3. Now the limit value, that is limit of x tends to pi by 2 of function for x, as here we are not going taking the value x as exactly pi by 2, we are approaching to pi by 2. So this x should be not equals to pi by 2, so function value will be this, that is limit k cos x divided by pi minus 2x. Now as you can see, if I put my x to pi by 2, so this will be 0 and the denominator will be also 0. It will be kind of not defined. So what in this case, what you guys can do, you can change your limit as limit h tends to 0. This formula always work when you have a trigonometric functions. So what you can do is h tends to 0, k, change your x as pi by 2 plus h divided by pi minus, in place of x what you do, pi by 2, what you do, pi by 2 minus sorry plus h. So as you can see, this both are same. Why? Where here you are approaching your x directly to pi by 2. Now here what you are doing, you are approaching to your h to 0. When your h is approaching to 0, automatically this part is approaching to pi by 2. That's what we want here also. So now what we can do here, so we can use the formula of cos a plus b, not needed that, we can do by that also, but here you can use directly that cos pi by 2 plus theta is nothing but minus sine theta. We're going to use this directly. We know that this is very trivial formula in trigonometry. So this limit will be limit h tends to 0, k minus sine h divided by, now the denominator will become minus 2h. So this limit will be k minus, this limit will be positive k by 2, limit h tends to 0, sin h by h. Now we know it. I think you can easily, this will click on your mind also, when your h theta is tending to 0 and you have a limit of the form, you have to find the limit of the form sin h by h, sin theta by theta. This limit is nothing but 1. So this value will be k by 2. Okay, now this is our limit value. To make the function k continuous at pi by 2, we want this limit value must be equal to function value. That is nothing but what we want We want that, that's how we can find the condition on k, right? So k by 2 must be equal to 3. So this implies our k should be 6. So this is the required condition on k. That means our k must be 6 so that the function will be continuous at x equals to pi by 2. Okay, so it's very easy. Like you can see, you can like come across like this type of question a lot, because you know, in this what you have to, like, there is a use of continuity. You have to directly, what you do, you have to just make your function continuous at that particular point. For that you have to make some restrictions on some that variable that is coming across in your calculations. That's a very easy question, but and this is also like a type of question that's both demands, right? You should do this type of questions practice a lot, because it can be like I can say this will come in boards for, I think, for 2 to 3 marks. Yeah, fine. For 2 to 3 marks, it can be in your boards, but I'm not giving that much high priority to these questions. But it is a very like good type of questions for you also. If you practice this type of question, then you can easily, because they are basic questions, but a high level of this can be asked in your boards. It's just using your basic knowledge of trigonometry here. Okay, let's move to the next question. Okay, the next question is question number 27. In that also, what we have to do, we have to make the function continuous at a given point. Our given point is x equals to 2, and our function is defined like this. Now, what you have to do, you have to again find a condition on k so that the function is continuous. Okay, I can give you it as a homework, because it's same as, and it's very easy to find the limit also, because it's a polynomial function. I can give you the value of k here so that it will be fine for you, and I think its value of k will be 3 by 4. Yeah, the value of k will be 3 by 4. You can easily see that your function value is 3 and your limit value is 4k, because x is approaching to k, so 4k. I'm giving you the answer also, but it's fine. So it is 4. You have what you have to do at the end. 4k equals to 3. So from here, what you get, your k is equals to 3 by 4. That's what you have to do. But it, by the way, it will be homework for you. Do it properly, right? Like find its limit, equate this limit to the function value. Now let's move to the next question. In this, all this question, we have to do the same thing. So this question also, we have to do the same thing. Like what we have to make, a function is defined, f of x is defined x, k plus kx plus 1 for x less than equals to pi, and cos x for x greater than pi. Now what we have to do, we have to like make the function continuous at this point, because this is our given point, that is x equals to pi. So may I do this for you? Okay, I will do this for you. Okay, so here as you can see, our function value f pi is defined as k pi plus 1. Our function value is this. Now the limit value, that is limit of x tends to pi f of x. This we want this limit value should be equals to function value. But as you can see, I have always told you, when you have a function, I just repeat my questions like same sentence again and again, but it will be very helpful for you. When you have a function that is splitting at a point in two different cases, like for less than that, but see, as you hear also, for less than equals to pi, the function is defined as kx plus 1, and for greater than pi, it is defined as this. So whenever you have to find a limit in such a case, find your left hand limit and right hand limit separately, so that you can like work on your main limit. So here, as you can see, our first we find our left hand limit. So our left hand limit will be limit x tends to pi minus kx plus 1, that is nothing but k pi plus 1. Now your right hand limit is limit x tends to pi positive cos x. So as you can see, this will be cos pi, and we know that cos pi is nothing but minus 1. Now we want that this limit value should be equals to this. That means for our left hand limit, so as we want a continuity at x equals to pi, so its limit must be exist. If its limit must be exist, this implies that my LHL should be equals to RHL. That means k pi plus 1 should be equals to minus 1, should be equals to minus 1. Sorry, it should be equals to it should be equals to -1. Now, as you can see, your left hand limit is nothing but your left hand limit is nothing but your function value also. So this is nothing but f of pi is equals to k pi plus 1, and it should be equals to -1. Now use this thing to find your value of k. So what is that? K pi equals to -2. So your pi will be your k will be -2 by pi. So what you have find your condition on k, that your k should be -2 by pi for the year, like for the existence of your limit or for the function to be continuous. Okay. So now this is also done. Now let's move to the next question. That is question number 29. Okay. So here you have to also you have to do the same thing. Here also you have to like find the value of k for which the function is continuous, and it will be homework for you. As you can see, I have already told you that. When the same type of question is repeating in your book, that means they also makes importance in the coming of the exams also, because when you are doing the practice of the same questions again and again, and it will be like good chance that they will come in your boards. Not I am saying that exactly this questions will come in your boards. I am trying to say this type of questions you can, like, values can be changed, question type can be changed, but like the knowledge you have to use there is the same. The idea you have to use there is same. Like you have to make your function continuous at that point. Find the condition on the variable that is coming in your across. Okay, so this will be homework for you. Here also you have to do the same thing. As you can see, it is same as 28. I'm not doing it because I have did the question number 28, because it is same as question number 28. Only the things are changed. Okay, so we are done with that's all for today's video. We have completed question number 26, 27, 28, 29 in this video. Now, like do these questions once by yourself. Do all the homework questions also, because it's very important for you guys to like keep practicing the questions, because like maths is until you like not practice the questions by your own, then you cannot do the questions in exams, because to do the questions in exams you have to get the practice of writing the questions, writing your ideas, how you should start, how your work should end. So that's why always practice by your own. Like you can watch the videos I am explaining, you can the question, you can use my ideas how we can solve these questions, but at the end you have to do the question. Okay, that's all for today. Do the homework questions as I said, and if you have any doubts, ask me in the comment section. Till then, bye. Let's meet in the next video. Please like, share, and subscribe this video so that you can easily reach us this videos for your own benefit. Thank you. Bye bye.